Good morning, good afternoon, everyone. Welcome to Business Finland Situational Awareness webinar. My name is Petra Söderling. I work for Business Finland here in the USA, and I will be your host today. I'm really happy to kick off the series on situational awareness. So the session we have today is a generic one. We'll talk about what Finland has to offer in the new space economy and situational awareness. We also have sessions coming up, one every week. The next one is going to be on situational awareness and forestry. Then we'll look at maritime, and then the last one is going to be on disaster risk management. Before we get started, I want to go through the house rules real quickly. So first thing, everyone is muted, but you will be able to ask questions during the three presentations that we have. I will read your questions at the end of the three presentations, so we'll have a panel discussion with all the presenters. You can ask the question anonymously, or you can give us your name and your company. When I read the question, I'm not going to read your name and company, but if you want to give it to us in case you want us to contact you later, that will be fine. This session is recorded, and the recording is going to be made available to you. We're also posting these on the Invest in Finland YouTube channel. Without further ado, I want to introduce our first speaker. This morning, he is Markus Ranne. He is the head of the New Space Economy program at Business Finland, my colleague back in Helsinki. Markus, if you want to turn on your video while I introduce you. There you are. Hi. So Markus, hello. He is the program manager of the New Space Economy program at Business Finland. Previously, he's worked in various project functions at Business Finland, also European Space Agency and IVO Power Engineering. He has a master's degree in electrical engineering from Helsinki University of Technology and an MBA from Aalto University. So I will make you a presenter, Markus, so you can start sharing your presentation.
Thank you.
Go ahead.
So hopefully this is visible.
Yeah, can you put it on a slide? Yeah, here we go. Thank you. Go ahead.
So as said by Petra, my name is Markus Ranne, and I am the program manager for the New Space Economy program at Business Finland. Business Finland is the national organization for innovation funding, export promotion, invest in activities, and also tourism promotion. And one of the activities we run with companies, various programs, and for me it is New Space Economy, which focuses on developing the commercial space activities in Finland. Today I'll be focusing on one area of activities, which is situational awareness, and try to elaborate to you a bit how we are building ecosystems in the situational awareness in Finland. So what do we mean by situational awareness in Business Finland and in the New Space Economy program? For us, this is a question of collecting information on multitude of platforms, from satellites, from drones, from land and sea-based sensors, collecting the data into a single database for processing with artificial intelligence or machine learning, transforming it into a understandable format for the user so that it enables rapid change detection and informed decision making. This is something that has been familiar in defense area for a while, but for us the focus is on civilian applications of situational awareness. Why should this interest you? Well, there are 4 different reasons why this is important also for companies. Being able to see what is happening around you and seeing what is changing, be it then positive or adverse, enables you to optimize your resource usage, manage risks, limit negative events, make informed and timely decisions. So all this contributes to your ability to do business, control costs, and increase profits. So I think this explains pretty well why this should interest any company in global operations. Application fields for situational awareness are numerous. Here you see some examples. As mentioned by Petra, we will later on look into a bit deeper to forestry, to natural disaster management and maritime. But already at this point, I want to give you a glimpse what all is possible. Forestry. So for forestry, use examples are, for example, pest control, finding pests in the forest and being able to see the damage in advance that's potentially developing, or managing your wood resources all the way from the woods going to your factory in a form which enables you to see what's happening at each step of the process. One of the Finnish companies operating in forestry area is called Terra Monitor, and they manage the world's most comprehensive and up-to-date cloudless map of the globe, using machine learning and artificial intelligence to clean the imagery and make it available to the users. Smart cities. This is again a bit different. So here the example of situational awareness solutions is actually a smart light pole, which can integrate both 5G transmitters and sensors in order to enable all the services that are made possible by the application of 5G into a modern city. In Finland, we have a project called Lux Tarim, which is a Nokia Bell Labs driven ecosystem combining 20 Finnish companies and research institutes which are specifically working on solutions based on 5G networks. In addition to being able to manage a modern city, it will also enable completely new business models which can be developed based on the infrastructure. Maritime services. For example, following ice or recognizing vessels and matching that to the AIS signals, or identifying vessels without AIS signals, so dark vessels. So this is also something that might interest border control. The company ICEYE is focusing on the use of synthetic aperture radar satellites and provides a constellation, or actually is building up a constellation. Not all the satellites are up yet, which will be able to point at any point of the Earth up to every hour and provide the requested imagery at any time of the day or any weather. All the images can be further processed by tools for analysis which are based on AI systems. Smart airports. Again, other kind of solution. Here we talk about digital twins. So building a digital copy of a running airport enables you to manage and develop the airport at the same time. So when you have the digital twin and you combine it with real-time data, you will be able to see what is happening on a live airport. You will be able to test all kinds of solutions and simulate options how to develop your airport without disturbing your everyday life. At Helsinki Airport, we have a group of companies working exactly like this, and they have built a digital twin platform for testing purposes. And smart agriculture. Here, for example, how to optimize your water usage, how to optimize your fertilizers, how to do precision agriculture or smart agriculture. Hyperspectral imagery is something that's being developed at VTT in Finland, and I think you will hear a bit more about that today. And currently, actually, we have a demonstration or proof of concept cube satellite flying on orbit, which demonstrates the combination of hyperspectral imaging when used on a CubeSat. And what we want to achieve with that in Finland is to be able to do smart agriculture on a global level. Of course, again, AI tools are applicable here as well. So that was examples of the uses. And I promised you in the beginning to tell you about the ecosystemic approach. So this all actually started end of 2019 and was finalized in 2020. What we took as a basis was exactly this picture and started mapping companies in the various actions, considering this to be a sort of technology platform where we can plug in Finnish or international competencies in order to build something that is bigger than an individual company can possibly provide. So you have here drones and the ground-based sensors, the satellites, the databases with the analytic tools, and also the user interface, which has to be there in order to be the information applicable to the user needs. We started to put the companies in here, and we soon realized that we actually have many of the capabilities, or actually we could pinpoint even all the capabilities in picture that we could serve with the help of individual companies. But now that we combine them into a platform which looks into a larger situational awareness system, we are able to develop services and solutions that are completely changing the game on a global level. The group of companies which started this work, it was some 20 companies, and now we are closing into 40 companies altogether. So also in Finland, the interest is being raised towards situational awareness and what we could offer with our competencies to the global markets. Another example is the Multicore Project, which is actually a co-funded project from Business Finland. So as I mentioned in the beginning, we do innovation funding and we co-fund projects. And in this case, we are talking about a co-innovation type project where we have both research organizations and companies working jointly in order to develop something new. So the research organizations have the advantage of combining their skills with the practical usage of companies, and on the other hand, there is fresh ideas being fed from the research organizations to the companies, and this enables to develop completely new kind of solutions, also in the situational awareness area. Here we're talking about future sensor technologies and related data analytics services. In this case, the participating companies are optimizing the sensors, especially to drone and small satellite platforms. And this is now a cooperation between VTT, Aalto University, and some 10 Finnish technology companies. So again, this is another way of building ecosystems. And with this, I hope that I am able to invite you to join into building these ecosystems further. Here are some points which I would like to raise why Finland would be a good place to cooperate and why you should be interested in cooperation with Finnish companies. As you can see, we are #1 in many things, and happy to say that these have also been evaluated by organizations outside Finland. So indeed, this is recognized also broader than just within the Finnish borders. But all in all, I would like to invite the US companies to join and develop new kind of solutions to the global markets. I was participating yesterday in a meeting, and one of my colleagues pointed out very well that regardless if the investments are going towards the US or towards Finland, the best cases are always the ones where US companies and Finnish companies are developing solutions for the global market. I think that was pretty well said. At this point, I would like to thank you. And if you are interested to learn more about Finnish solutions for situational awareness, you can always contact me. Or if you want to click on the link later on when the presentations are provided, you may go to the Finnish Solutions for Situational Awareness brochure and find more. Thank you very much.
Thank you, Markus. That was really interesting. I have questions already, but I'll take all the questions at the end of each presentation. So next, we are going to have Juha-Matti Liukkonen from Reactor. I'm going to make you a presenter. There you are. Nice to see you. So let me introduce Juha-Matti, or Yusi Liukkonen. He is Reactor's Director of Space and New Technologies, with over 25 years of experience in designing and building systems at the intersection of software, hardware, and humans. Juha-Matti has gathered insight from several industry sectors. Yusi represents the Finnish space industry in the National Space Committee. He's participated in updating the National Space Strategy Action Plan, and he acts as the chairman of the board at a space tech startup called RSL. So please go ahead and start your presentation, Yusi, if you're able. Okay, you are on mute. We can't hear you.
This probably helps.
That helps. Thank you. Oh, yeah. Okay, we can see your slides too. Okay. Not on slide share mode yet. Here we go. Thank you.
Nothing exploded. The wonders of modern technology.
Yeah.
All right. Thank you. Thank you very much, Petra, and thank you, Markus. As noted, my name is Juha-Matti Liukkonen. I am the director of the Space and New Technologies area at Reactor, and also the chairman of one of our investment portfolio companies, the Space Lab. And it was nice to see in Markus's presentation both Reactor and our Space Lab represented in that ecosystem diagram in several places. And today I will be talking a bit on situational awareness systems and how we see their role in a world where increasing automation, rapid technology development, and disruptive global events shape business needs at unprecedented speed. And I will use this opportunity to highlight our slice through that ecosystem diagram. What is the aspect that we find most relevant, where we have the most value to provide? And this hopefully gives you some idea on how to interface with us in this context. But first, like Markus started a little bit with definitions, let's talk a bit about definitions. Situational awareness systems are inherently decision support systems. So their purpose is to support and bring efficiency to goal-oriented activity. And when we're talking about situational awareness systems, we quite often compare apples to oranges. The term is used to describe quite different systems. There are a number of ways we can classify different situational awareness systems. First, there are different levels to a situational awareness system. Here I'm showing the model as defined by Ensley and drawn by Dr. Peter Langton. And some systems implement only level 1, the perception layer, while some systems implement levels 1 and 2, and some systems all of it. Some situational awareness systems may be focused on data aggregation, merging data from several different sources such as satellites, ground-based sensors, and internet sources. Some systems may be more focused on comprehension, detecting objects and patterns from the data. And the most challenging part is, of course, projection of the future. And it is often limited in scope, and its value is always dependent on being relevant to the user's need. Now, we can also classify situational awareness systems to operational, tactical, and strategic ones, depending on which layer of business they are used in. Take an industrial machine, such as an advanced logging harvester. It has at least sensors, data aggregation, and some kind of a perception layer. Depending on the level of automation, it may act as a decision support system for the human driver, or it may even be a real-time system to drive automated functions. This is what I'd classify as an operational situational awareness system. It is primarily addressing elements and events in the immediate vicinity, physical vicinity of the system, and may have real-time requirements to drive automation. Being from an embedded systems background, this genre I find personally particularly interesting because tinkering with intelligent robots is always fun. Now, you may also have a situational awareness system that is focused on operating a fleet of machines in a given work site. In a similar way, it has sensors, data aggregation, and a perception layer. It may be sending instructions to individual machines operating in the work site. This type of a system is what I classify as a tactical situational awareness system. The physical range of the covered area is larger, and there are no hard real-time requirements, even if automation is involved. You don't need to be aware of the immediate vicinity of the target systems or their exact location or exact activity. You just need to know roughly what stage of work is going on, roughly in which location, in order to orchestrate the larger whole. And then as a next layer, we can imagine a large corporation managing resource flow from several work sites to several industrial facilities. You need to know the status of each site and roughly what and when they are producing so that you can schedule the logistics chain and drive business processes. Now, each of these examples are situational awareness systems operating possibly even in the same value chain and maybe even interconnected with each other. And they are all acting as decision support systems for some business process, which can be automated to some degree. And these use cases, however, require quite different sensor inputs and integrations, and they have very different user groups and very different real-time requirements. Now, going through these classifications may have been a bit academic, but I kind of wanted to open up the very generic term that we're discussing here today to lay some groundwork for my main points. In order for you to gain a business benefit of a situational awareness system, you need to be looking at your business needs and what decisions you need to make in that context. The situational awareness system as a decision support system needs to support your decision-making processes, automated or analog, with relevant and unambiguous information. Gartner discusses digital twins in the recent publication, How Can We Use IoT and Digital Twins to Reduce Costs After the COVID-19 Lockdown. Digital twins are models that aid in the comprehension and projection levels of a situational awareness system. What I like about Gartner's approach is their direct consideration of end user needs. In other words, what benefit or outcome is wanted. This requires understanding of business needs and business processes. And once we have that understanding, we can adapt situational awareness systems to support the business relevant decision making. Now, we can build satellites. We can use existing satellites in orbit to collect detailed information from activities around the planet. These days, we have unprecedented visibility to activities anywhere and capabilities for even more. Here, I'm showing just some pictures of the US-based Planet, which is flying a fleet of nanosatellites equipped with normal cameras. ICE-I, who are flying a fleet of radar satellites. And of course, an image of the miniature hyperspectral imager that we're flying in the Hello World satellite. All of these kind of systems can provide us new ways of looking at things. Fast time resolution, so frequently updating data at new areas of the spectrum that we may not be used to have more information to digest in our situational awareness systems. But it is your business need that determines which of those might be relevant, and also what are the important things the system needs to comprehend out of the flood of information. Now, the landscape and the needs for situational awareness systems is developing at a fast pace. In the operational side, we have steadily increasing automation. In the strategic level, we have the need to understand and respond to a rapidly fluctuating business environment, influenced by global and sometimes very disruptive events, such as COVID-19, Brexit, or climate change. And the sensor and also the comprehension technologies are advancing rapidly, allowing us to observe the environment in unprecedented detail and also make better sense of it than before. In order to bring the benefits of the new sensor technologies into use, and to answer the new and emerging user needs, it is not enough to buy a situational awareness system and call it done. You actually need a continuous process to detect most valuable developments in both the demand and supply side, and bring the necessary support for those into your situational awareness system so you can retain your competitive advantage that the situational awareness system gives you. In practice, this translates to having the capability, both technical and organizational capability, to update the system as your needs and available technologies evolve. In order to make this possible, you need to consider what and how to buy, what capabilities do you need in-house, and who are the key partners to work with. And in a more technical perspective, you need flexible solution architectures, API-first modular designs, and capability to embed machine learning and analytics at multiple points. Reactor is a consultancy. We help our customers across the world to develop new business and improve efficiencies by designing and implementing better processes for value delivery, and designing and developing digital systems to support those revamped processes. Based on our experience, most situational awareness systems share common elements, and they also always need custom integrations and interfaces. We have found that we can provide the best value by leveraging existing toolkits for sensor fusion and data comprehension. So we have productized solutions for those components. It is then fast and efficient to start building the solution to the customer-specific scenario when the field-proven core modules provide a lot of the computational heavy lifting and base integrations out of the box. Now, we have also invested into a niche-based startup, RSL, via our ventures arm, RSL develops state-of-the-art nano and even microsatellites for sensor and communication needs. These are, of course, the type of sensors that allow us to build situational awareness solutions that can utilize near real-time information from anywhere on the planet or the near space. And RSL is currently working, as Markus already alluded to, on establishing a high time resolution hyperspectral imaging service using their nanosatellites and a novel imager from VTT. So this is the kind of sensor technology that we're also working to advance in order to support the main track, for us, the main track of building new business solutions for our end customers. So we're building a toolbox, a solution toolbox, which is a good fit for the ecosystem thinking advanced by Business Finland. We are currently operating globally with offices in New York, Amsterdam, Helsinki, and also Dubai and Tokyo, so we can offer support for our customers locally in each of our target regions. I hope that this gave you some new perspective on how to think about situational awareness and what things to consider in that context to be and stay competitive in the rapidly changing world. And if you wish to continue discussions on these topics, I would be happy to have follow-up discussions where I can also involve our subject matter specialists as needed. Thank you for this opportunity.
Thank you, Juha-Matti. That was very interesting. So our next speaker, Marko Höyhtyä, is from VTT, which is Finland's national, I'm going to say national, correct me if I'm wrong, research lab. And I kind of like the dynamic that we have. So first speaker was from Business Finland, which is the government's innovation funding arm. Second speaker from a private company. And I want to say, Marko, that VTT is kind of the public-private partnership player in all of this. I hope you agree, or if you disagree, then shout out.
I agree.
Good.
So it's the Technical Research Center of Finland.
Very good. Okay, you have the presenter. There we go, and you can make it on the slideshow so we can see it better. There we go. Your panel, the GoToWebinar panel is overlapping. It's gone. Okay, you're good. Good to go. Thanks.
All right, thank you, Petra, and thank you, Markus and Yusi, for setting good foundation for my talk. So the previous talks provided a big picture on this area, and I will talk a couple of specific technologies related to this. So I am Marko Höyhtyä, coordinating the space technology research at the VTT, and we have a little bit more than 2,000 people working on technology research on different areas, mainly in Finland. So today's talk is considering two main topics. I will talk about hyperspectral imaging and nanosatellites, and then I will also talk about the future connectivity that integrates different systems together. So let us first take a short overview of these topics. So hyperspectral imaging means that you can obtain spectrum for each pixel in the image to find objects, identify materials, or detect processes. And of course, it has many applications also in terrestrial domain, but from the space, you can, as was also previously described, use for different purposes. In agriculture, for example, you can follow development and health of crop, or how the fertilization is divided to the area. Then regarding the satellite terrestrial connectivity, it provides means to share the information to and from remote locations as well. And And there are some of the things that are right now happening that are really interesting. There are new kind of satellite systems in addition to those small satellites. The standardization in 5G non-terrestrial networks is ongoing, and there are LEO mega constellations, even hundreds of satellites in the same systems to provide connectivity globally. They may change the way to communicate in the future. And of course, many application areas for those systems as well. To mention a few, public safety, they need also connection in remote locations and reliable redundant connections also during the times when the infra is destroyed. And naturally, maritime users need both systems, satellites when they are far from the shore and other kind of systems when they are closer to the shore. So hyperspectral imaging, let us take a deeper look about those miniaturized instruments. So we have been able to miniaturize the hyperspectral instruments to make them possible to use them in the nanosatellites while achieving good performance and keeping the costs at a very acceptable level. And a very good thing in the ability to use the nanosatellites compared to large satellites is that nanosatellites are cheap. So with the price of a single big satellite, you can create a constellation of nanosatellites equipped with those high-tech instruments, and you will get more data about the environment, reduced revisit times on the area, and so on. Also, what has been really good from the small country and different organizations' viewpoints is that it enables us to reach the space and really create and use technologies in the space domain. So the traditional optical remote sensing methods require very good attitude control to be able to use them, and they are not suitable for CubeSats. But we have been developing those instruments with tunable Fabry-Perot interferometer filters to make them suitable also for the unstable platforms. And there are several advantages of the miniaturized instruments with FBI filters. So they are software programmable over the air, so we can adjust the wavelength that we are using in the imaging. We can also reduce the downlink data the way it is possible to send over the connectivity link. And of course, this allows us to use the same hardware for different applications. So we can tailor over the air the system in the orbit to gather information with different wavelengths for different purposes. And this is showing an example figure on the situation. So on the left-hand side, you see the traditional spectral image. And on the right-hand side, you can see the hyperspectral image of the same target. And you can see that it reveals more information. You can see what kind of vegetation there is. You can see where the water flows and so on. So allowing to gather more information from the target. So as was already mentioned, there are those satellites in the orbit. So together with Reactor Space Lab, the first ever nanosatellite with hyperspectral camera on board was launched June 2017. And the next version with a shortwave infrared version was launched next year. Both satellites are still fully operational in the orbit, providing information for the different purposes. And very lately, our camera was also launched to gather information about the atmospheric gases this month to the orbit. So those small milk can size satellites are really good tools to gather information about different areas and for different purposes. Then regarding the connectivity, how will the future networks look like? This is a vision for three-dimensional network that we have been creating during our strategic collaboration with European Space Agency. So you can see that this is a layered architecture. So in the terrestrial domain, you have the typical mobile networks and users. Then in the airborne, you have drones and high altitude platforms. And in the space, you have different sizes of satellites in different heights, in different orbits. And those, they can be separate systems or they can be connected to each other and integrated to provide services equipped with both connectivity and remote sensing capabilities. But of course, this kind of integrated network, it provides both, enables both many promising applications, and also there are challenges how to manage this thing. But let us zoom in to this figure to see some details. So if we think about this integrating satellite and terrestrial systems, where you can use both the satellite and the mobile base station to provide services, even with the same type of air interface, 5G air interface, you can use the same system to provide multitude of different kind of users and user segments with high and low priorities. So here we have autonomous mobile systems, public safety users as high priority users, and then low priority users for entertainment and so on. And in the 5G, for example, you have the possibility to create network slices for the network. So you have virtual network inside the physical network where you support those high priority users and guarantee that their quality of service is always fulfilled. But if we again zoom to the maritime use from this figure, you can see that from the autonomous ship point of view, the situational awareness is of course very important. There are a lot of onboard systems that are producing data. There are machinery and propulsion systems and their sensors and actuators. You have navigation systems, safety systems. And in order to avoid collisions with surroundings, you need to have collision detection situational awareness sensors. And each of those sensors and systems are providing data. And in order to remote control center to have information based on which to control the systems and provide the control data to the ship, you need to have the essential data to be sent for the remote operator. So all the environmental and ship status data is sent to the operator, and based on that data, she may then, for example, demand route updates. And I would like to show you how this looks like in the Arctic environment. We have been modeling and simulating both the satellite system and the ship operating in the Arctic environment, and this is how it could look like. Okay, so just to conclude, Finland is already established space country, and we have a knowledge on suitable technologies for the situational awareness, such as hyperspectral imaging, 5G and nanosatellites, and we know how to apply them to the numerous use cases, including autonomous shipping. Thank you very much for your attention, and you can see my contact information if you are willing to collaborate also outside this event. Thank you very much.
I realized I failed to introduce you before your presentation. I got so excited about the VTT's role, so I just want to do a proper introduction after the fact. So you just heard from Marko Höhtyä, who he obtained his Doctor of Science in Technology degree on telecommunications engineering from the University of Oulu, where he currently holds adjunct professor docent position. He's currently working as a new space co-creation manager, coordinating space technology research at VTT. He was a visiting researcher at the Berkeley Wireless Research Center in California, 2007-2008, and a visiting researcher at the European Space Research and Technology Center in Netherlands last year. His research interests include critical communications, autonomous ships, and resource management in terrestrial and satellite communication systems. Dr. Höhtyä has published over 70 scientific articles, and he's also a senior member of IEEE. So that's quite a resume there. Thank you.
Thank you very much, Petra.
I am going to ask all of the panelists now to turn on your videos, and I'm going to grab the presenter role if I can from Marko, and here we are. Getting dark, Marcos, where you are, but
yeah, I noticed now that I see the video. Sorry for that. I can try to change the light a bit.
That's okay. Yeah, thank you. Well, you know, this is a global exercise, so that's what happened. I have tons of questions. We have 10 minutes, so we will not be able to take all of the questions. But maybe I want to start from the end, because I think a lot of people found the three-layer, three-dimensional networks, Marko, that you presented quite fascinating. And
right.
So the question is, I think the technology is pretty clear, or like as clear as it can be to the layman. But what about you mentioned the operator. So does VTT have models for who the operator is, or that's open to be discussed? You guys are just providing the framework, and it's up to companies, countries, organizations to take the operator role.
Well, that is a good question. The basic thing is that even though there are different layers and systems, they might not be under the same operator. So if you combine a terrestrial 5G network with the satellite system, each one of them might have their own operator. So let's say the LEO satellite system, they will have the license, they will have the frequency licenses, and they will talk with ITU to get their operation ongoing. Whereas for the frequencies and operation nationally, let's say in Finland, the operator talks with Traficom. And of course, there are then cross-border things also with this simplified figure where you need to have separate contracts in place. But of course, VTT is not going to be the operator of those networks. We can be the technology provider, but we assume other participants to be the operators of the network.
Yeah, you mentioned in the beginning, though, that the whole idea of the three-layered approach was planned together with European organizations. So is that a European approach? Can American companies come in and plug into that system or that thinking already now?
Sure. So this is the vision of European Space Agency, or together with them. But of course, there are also, if you start looking at the research papers, there are already a lot of American organizations talking about same kind of vision. So it is kind of agreed already globally that this kind of things will happen.
Okay, and then I want to come to Markus, you showed that the blue slide where you had the architecture, and then Marko showed this 3-layered. It was sort of overlapping, but not exactly. It's are we looking at different visions here, or what's kind of the story?
Was that now for me or?
That's for you, yeah.
That's for me. Okay. So indeed, we're looking at the same vision. It's just from a slightly different perspective. So the picture that I showed a, let's say, technical diagram of the system, which had all the various parts, the sensor platforms, the communications, the database, and the user interface. Whereas what Marko was showing was more depicting the various layers that you have involved in, let's say, terms of height of operations, if you want to call it like that. Because of course, if you are on the let's say satellite level, you are looking at not as much detail at things as you do from drones, but you cover larger areas. And of course, if you want to make global solutions, satellite is pretty much the only way to scale up. So you have to integrate all the layers shown by Marko if you want to provide services which we want to both, or which can both address large geographical areas, but also provide the required level of detail.
Yeah, I'm looking at the attendees in this webinar today. So we have sensor providers, we've got drone people. So Markus, the picture that you showed is the assets that Finland has. And I guess, Marko, you were showing the theoretical vision. Is there, do we have any gaps where we could invite US companies to kind of fill that void and fill this void?
I think it's not really a, let's say, it's not really a question of addressing gaps. I would rather address opportunities that could be jointly prepared for the global markets, because as I mentioned in the quote I gave in the end, from, unfortunately it was not thought out by me, but nevertheless, the best cooperation between US and Finland has always been looking outside both countries to develop something completely new.
Yeah, I really like that. But so still, maybe Juha-Matti, you guys are, you're both a consultant, but then through the subsidiary, you are a manufacturer of CubeSats as well, and you launch them, and so you have different service models. Would you say that is the barrier to enter this business, does everyone need to have a whole holistic global solution available, or are there opportunities for let's say a hyperspectral camera manufacturer to kind of come into this ecosystem? Or Markus, you also called it a platform, or does it always need to be a full solution? Did you guys look at that when you were planning your business, your modus operandi for the subsidiary?
That's an excellent question, Petra. The general thesis for New Space is that when you take a startup mode and you implement a fully vertically integrated solution, so you have your own spacecraft technology, your own sensor technology, your own service layer on top of that, gives you speed and efficiency to introduce new services to the market. This, in my view, is applicable in kickstarting completely new type of services. But once that becomes an established business and you start to scale, then you start to see the layers. The business model for managing a constellation is completely different from the business model of providing ground station support, and again, completely different from the actual service model of the end user services. So while I see that in the initial stage, these type of new space companies like Planet, ICEYE, our Space Lab, initially they get more efficiency by being completely integrated. As they start to scale up, it becomes more efficient to start to split those up in, and create an ecosystem where other parties can join in. I hope this made sense. It's not a trivial answer.
Yeah, it made sense. It's interesting. So you're saying first you imagine or create a holistic solution, and then you start to divide it up. I was also thinking from the other way around. You had this forest machine manufacturer, and both Markus and Juha-Matti, you talked about digital twins. So it's possible, and a lot of companies already currently have digital twins for their maintenance modes, but they're not maybe looking at situational awareness. Can you see that situational awareness can also enhance existing things like flexible manufacturing and maintenance and fleet management?
Absolutely. And I would like to take two tracks to answer this. One is that first, situational awareness needs to develop to match the needs of industrial automation in these various application scenarios. So there's definite value to be gained by advancing your situational awareness solutions. In another track, looking at this space-based single sensor type of solutions, we quickly find that in most industrial applications, you actually need to merge multiple data sources. So being able to do the sensor fusion, combine multiple instrument sources are required in order for you to get actionable insights out of that data. So in that sense, what we just discussed in the previous question, being completely vertically integrated has its limits once you get to the service layer and the complexity, because it constrains the complexity of the end user use cases you can solve.
Thank you. Yeah, there are a number of other questions, but I'm afraid we're running out of time. Just to conclude, I guess what we could say is, if we look at the space economy in Finland and the situational awareness offering, so there's an offering in place. Finland has strengths, but we also want to invite US companies to plug into that ecosystem and utilize the assets that are already there, either in supporting your existing business or creating new businesses for you. But we also have these fantastic private companies where you can just plug in and work in parallel, either as a customer or maybe a service provider or another type of collaboration. And as always, in all of the Business Finland cases, I'm here based in the US. My role is to help American companies discover these opportunities, make most of the technologies and research opportunities that we have in Finland. So if you have any further questions, just email me. You can just respond to the emails that you have been getting from the webinar organizing. And don't forget to sign up for our next week's webinar is on situational awareness and forestry, the following week on maritime, and then the fourth one is on disaster risk management. With this, I thank all the panelists. Thank you so much for staying up late and being with us today. And thank you all of our attendees. You will be hearing from us in a couple of days with the recording. So check your inboxes. Thank you. You all have a good day and good night.
Thank you. Bye-bye.
Thank you. Goodbye.